If you haven't had a chance to watch the previous video and actually do the problems for yourself, I would highly encourage that. It would make this video a bit more meaningful and helpful. And of course, you are always encouraged to please retry the problems. You might even just want to pause the video while we're doing some things and try the problems out again for yourself, or try to get ahead and see if you can figure things out without me. Here we go, problem 2, round 2. So we're going to add a few more techniques that you've learned in pre-algebra and in algebra 1. The greatest common factor is, we kind of showed that previously with problem 1 part D in the previous video, where we were factoring out what was common, right? So for example, if we wanted to break up A, we can't do difference of squares. We could move this over, right? Don't write this down yet, but we could move this 6x over to make it a negative 6x. However, this is not like the previous problems where you could square root, because the goal of this is to get the x by itself. And when I do this, I have an x on both sides. So this is not a logical process to follow at this point.
I'm gonna put some dirt in your eye.
But what we do note is that they both have an x. So if I were to break this up, right? If I go pre-algebra style on you guys right now, and I break this down, x squared, there's an x and an x. 6x is 6 times x. And we note that each of these has an x. This would be the greatest common factor. So I'm going to pull out this x and count it once. And whatever is left over goes inside. And don't forget that this is all equal to 0. And if you look back at your introduction to quadratics notes, we had a few problems like this, right? This is again where we separate and solve. And so we do that, right? X is equal to 0, x plus 6 is equal to 0. And then we get our two solutions. One of them is x equals 0, and the other one is x equals negative 6. And again, because it's quadratic, right, it has a second power, we're expecting to get at most 2 answers, and so we've been getting them.
They love me.
Part B only has an x right here, an x squared, so you know that we could get away with moving this 5 to the other side. But we can't square root this yet, because I need to divide this 9 to both sides. And now we can square root, and when I square root, I pick up a plus or minus. And I'm going to kind of do some work with the square root. I can split it up like that. Negative 5 is negative 1 times 5. That's the same as square root of negative 1 times the square root of 5. By definition, a square root of negative 1 is I.
I'm gonna put some dirt in your eye.
The square root of 9 is 3. That was nice. That was nice. So what we get for part B is this, or in other words,
I'm gonna put some dirt in your eye.
so we have this, and we could of course split it up. So we either have I radical 5 over 3 or negative I radical 5 over 3 for our two solutions for this quadratic for part B. For part C, this is looking pretty nice. Let's take care of this negative 2. That gives me x squared is equal to 9. We square root both sides. That gives me a plus or minus. But what's the square root of 9? It's 3. So again, I've said this multiple times, but I want to make sure I'm letting you know how this works out. We pick up a plus or minus when I square root to solve for x. Why am I square rooting? Do I always square root? No. We only square root for x if it's squared, because that gets rid of the squared. And then the square root of 9 is 3. So when I square root the 9, and if it's a perfect square, I no longer write the radical sign. Okay? We pick up a plus or minus to indicate that there's two answers. There's either a positive 3 or there's a negative 3. And again, you can always check and confirm to see if it's true and if it works out. For example, if I take this answer and plug it into x, right? If I set it up as negative 2, negative 3 squared, that should equal negative 18. And it does. For part D, if you want to feel brave about yourself, solve part D two different ways. Try difference of squares, and then also try moving over the 4 and then square rooting. If you want to pause, try it out. So I went ahead and did in both ways for you to compare. We get the same answers in both cases, a negative 2 over 5 or a positive 2 over 5. We get that over here as well. The difference of squares happens to be shorter, but it's also more sophisticated, so you have to be comfortable with some mental math and just some premonitions to what's going to go on with the problem. We call that mathematical intuition. But if you are feeling more mechanical, that's perfectly fine, because either way we get the same solutions or the same roots. For part E, we're not going to move things over because I have too many x's, right? I have an x in this term and I have an x in this term. So we're going to have to pull out a greatest common factor. And we get this. And if we separate and solve, you're gonna get these two answers for this quadratic. Part F, here's another grouping one. So remember how we do this? We kind of like do an imaginary split down in half. We focus on the left-hand side. We pull out the greatest common factor. And then after breaking that down, we write whatever's left over. And if I know it may appear as I'm going a little bit fast, but I'm actually putting trust in you. I'm kind of not giving you all in-between explanations because we did that already in the previous video. So I kind of want you to have some faith in yourself. I'm giving you enough steps to come along the way, but you might need to break this apart, right? You might need to actually break it apart as 2 times x plus 2 times x and circle the common things and then pull out the common things and then underline whatever's left over and then put that in the parentheses, right? I'm trusting you to be able to know how to do those things if you need them. If I show you again all the steps, then you might not have that trust in yourself. Okay, now what we do is we look at the other part that we didn't look at before. Now this one I'll do for you because this part's a little bit unique compared to last time. You're thinking, well, Mr. Ver, there's nothing really that's common except that negative. I totally agree with you. So if I were to break this up, I have a negative 1 times x minus 1 times 2. Okay. And truth be told, I want to pull out this negative 1. And the reason for that is because if I do grouping right, and hint, this is a big left column idea. If you're doing the grouping method, and if you do it right, whatever's in this parenthesis is going to be identical to what's in this parenthesis. And if they're not identical, you did something wrong. So you might want to pause me, rewind the last 5 seconds, write those words down. Okay. Now, what's left over? I have this x. And then I took out the negative 1, so I'm left with this positive 2. And whoop-de-doo, what I have in these parentheses is the same. That means I did something right, or I totally tricked myself into thinking I did something right. Either way, they're identical, so we're happy. All right? We count those one time, and then whatever's on the outside becomes the other parenthesis. The original problem, of course, was equal to 0. We separate. We solve. And we get these two solutions. We get 1 over 2 or negative 2. Again, this is a quadratic because the highest power is the second power. And we expect quadratics to have up to 2 answers. And we've been seeing that in all the cases that we've been looking at. We have 2 answers. Again, if you want, you're encouraged to take this answer and plug it back in to each of these respective positions that have an x variable. Don't forget to use parentheses, order of operation. If you do everything right, you're going to make it equal to 0. If you do the same thing with 1/2, you're going to make it equal to 0.
They love me.
Well, good gravy. That was fun. Summary. While summarizing your learning and jotting down important reminders to yourself, please note how most of the above need to be equal to 0 before solving.
They love me.